So today is the last day of content review for Module 2. We'll be covering defensive coding techniques in Chapter 11 of the textbook. We'll be hitting the high points, and we'll also provide some assistance in case any of our students would like assistance with the assignment and solutions, the solution for Module 2. I want you to notice that the Module 2 study guide has been updated. And in particular, there's one thing I want to call out. So early in the course, we talked about how security breaches can occur between major systems or components of a scenario. And so the goal of this module is to look at hardware, software, and services gaps, right? Exposures. We talked about fault tolerance for hardware, and that has to do with the redundant array of disks. But I want you to see a pattern here. For software, we talked about data exports. And when you export data from software, you're basically capturing an extra copy. It's a redundancy, right? Redundancy is another word for fault tolerance, right? You have a fail safe in case something goes bad, right? And this is so overlooked because it's a very neglected security component that causes a lot of heartache. People have tax return software. They have checkbook and banking software. They have all sorts of things in the cloud. And if that cloud account is compromised, you'll never get it back, right? So that aspect of fault tolerance is important. It just has a different name, right? Data exports. For services, we talked about fault tolerance and how you can use network load balancing, which is an example of multiple DNS servers that take turns answering the requests for domain names. That's called round robin. And if the data is something that changes frequently instead of using network load balancing. So the distinction between network load balancing is that it's all the same content, right? But there are cases when more than one server is needed, and there's real-time replication of multiple copies of the same data because that data changes all the time. So when you have servers like an email server or a database server, right? That information is changing constantly. And we can still provide fault tolerance by doing something called clustered services, right? So we replicate the data that's changing constantly with a server cluster. That's different than network load balancing conceptually, okay? And that's the main difference. In any case, fault tolerance is an essential measure to protect against losses with services. And then there are hybrid scenarios. In our last class, we talked about how Apple was no help. A woman was reporting first to the Wall Street Journal and then Business Insider magazine that her phone was stolen. Everybody remember this? The iPhone was stolen?
Yes.
Yeah. So what's the solution there? You have fault tolerance. If the woman had set up two-factor authentication, the thief would not have been able to access the iPhone. If the woman had set up an additional Apple ID on her MacBook with administrative privileges, then she would be able to get on the MacBook and then recover the data. So again, fault tolerance or redundancy with each of those scenarios, there's a pattern there, okay? So even if you're dealing with just hardware, dealing with just software, dealing with services, or a hybrid situation, then you are looking at redundancy or fault tolerance to save the day, okay? Did everyone see the article that I sent earlier today, where I said this is a good example of security challenges that hits services? Does everybody know what IP telephony is? IP telephony?
No.
So what do you suppose telephony sounds like? What's that word? Sounds like what word?
Telepathy?
Yeah, sounds like what common word does that sound like? Have you ever heard of a telephone? Just a plain telephone?
Telephone.
Yeah, I was not trying to trick you, right? So when you use a data network to do telephones, that's called IP telephony, okay? And there is a protocol, there is a network service that runs on data networks that allow you to use a phone over a data network, okay? Another name for this is VoIP. You might have heard the term VoIP, voice over IP. So you have a phone, right? And Cisco is a huge partner in this. So they create data networks. Their equipment and infrastructure is famous. In fact, when you look at the biggest three industry leaders for hardware, operating systems, and networking, hardware, it's Intel. When it comes to operating systems, it's Microsoft. And when it comes to networking and telephones, well, telephones, it used to be different, but for networking, it's Cisco. So those three are considered like the three big leaders in those three marketplaces, right? So if you think networks, data networks, Cisco is the reigning champion, okay? They are known all over the world and their products help make things work. Now, when you put voice telephones over the IP network, that's called VoIP, okay? VoIP, voice over IP. So it's telephone voice over a data network. Does that help answer the question?
Yes.
So the internet police, well, they're not necessarily the internet police, but they are cybersecurity experts from the Cybersecurity and Infrastructure Security Agency, right? So this is an important federal government agency. It just released security advisories for Cisco IP phones. Many office phones now use a data network. And this is the nature of the security advisory. So it's a good example. It's just these phones. So those phones have a hardware component and a software component, and they run on the service that you have to have for VoIP. It's a separate service, it's a separate networking protocol, and there's a hardware, software, and service component. Now, specifically, when you get in here and you read about this, it might say, well, it has to do with the hardware specifically. And the hardware is compromised in this manner, and they're trying to come up with a firmware update, a software patch, something, right? So there's a software component. Could also have something to do with an exposure on the network, the data network for the service that the phones use. It's a hybrid situation. Put another way, it's another example of a hybrid situation. And I didn't include it in this version of the Module 2 study guide draft, but when I finish this study guide today and put it out there so you can get ready for your first attempt of the Module 2 assessment once we come back from spring break, the Cisco thing that I sent you today will be also added to this, right? It's another example of a hybrid scenario where all three of those things are important. Now, I did in the next draft of the latest draft of the Module 2 study guide, I did update and explain buffer overflow, right? So the stuff that we covered in class on Wednesday has been added to section F. Today we'll be section G, and then I'm gonna drop the thing about certificates and secure socket layers. We'll cover that in our network security module later this season. All right, so what I'm gonna do now is go into our review of safe coding practices. Okay? Any questions before we begin safe coding practices?
No.
Okay. So software developers, right? The folks who create programs, there are different categories of software problems. And so the textbook author in chapter 11 wants people to understand you can have insecure interactions between components. So what do we mean by that? Software modules, software functions. There can be an insecure interaction between those. Another thing that happens is that there's risky resource management. The idea of a buffer overflow is an example of that. So even though we treated chapter 10 separately as a special topic, when you have memory exploits, when you have memory attacks that are devised to take advantage of the random access memory, the live RAM memory, that would be a resource management and how the resource is exposed. It's not about the components between functions. It's about the resource itself. And then there is a third category of software error we call porous defenses. A porous defense is where you have software in order to work with trusted data, there has to be authentication, there has to be authorization. This has to get back to the AAA: authentication, authorization, and auditing, right? So AAA means authentication, that's authorization or access control, right? So when we're working access control, that's the nuts and bolts of authorization. That's actually going to be a special topic in module 3 when we get back from spring break. I'm going to show you how to change the way that data authorization works on a system or on a device so that you can lock out the bad guys, okay? So when we say that there's a software error generically that centers on a porous defense, what we mean is that it's like a screen door in a submarine. The software is not designed properly to include authentication. It is not designed properly to include criteria for appropriate authorization or access control, right? There's missing encryption for sensitive data. If there is sensitive data in an application and it's not encrypted, when it's stored, that is a porous defense. So the word porous means full of holes, okay? Does everybody understand that? Look at this one. Use of a one-way hash without a salt. Did we talk about salts and hashes? I thought we did. We talked about how the salt is an extra randomly generated value based on the differences of the user, the differences in each system that are unique, and that's used to calculate the hash. So a salt is an extra hash encryption component. It's a wildcard, a local wildcard. So remember that a salt is a local wildcard. Now, the fact that we're talking about hash, there's actually a food called hash. Has anybody ever heard of hash as a food? Like, I'm eating hash with my potatoes.
Hash brown?
Yes, you've heard of hash browns, right? So hash is like a meat product. It's kind of like Spam. Have you ever heard of Spam?
Yes.
Okay, so if you take Spam and you mush it up, and you just leave it loose, that's like hash. It's a meat product. It's a kind of a meat byproduct like spam. And it's very salty. So when people are talking about salting the hash, you know, it's funny, but a lot of students get hungry and we're like, well, yeah, but we're talking about encryption here and not about a food thing. But maybe that deep processing in terms of mental memory, maybe mention of the fact that hash without the salt is bad. In the same way that having spam that has no salt would be blah, right? This one, okay, so you don't have encryption, you don't have trusted inputs. It has to do with privileges. There are permission assignments. These are defenses of resources that have holes in them. Any questions about the three broad categories of software errors or software challenges? And then what's going to happen is we'll talk about some safe coding practices that eliminate this first category, the interaction between functions and between modules. Then we'll talk about what we can do to resolve the resource management software problem. And then lastly, we'll talk about how to eliminate the holes in our software defenses, okay? Does anyone have any questions or comments based on the information presented so far? Anyone? I am... Okay, so let's talk about security flaws, if there are no questions. Can somebody unmute your microphone to let me know that you're still with us?
Yes.
I'm
Yeah.
still with you.
Okay. So security flaws, right? When we talk about security flaws and we're talking about those, each of those broad challenges, web application security includes 5 related challenges to the software code, right? Now we talked about validation of input before. So you want to trap the input that somebody's putting in there. You want to make sure that it meets certain criteria. It's not a bunch of gibberish. It's not excess data. It's a serious problem. I need a second. Please hold just a moment. I need a 2-minute break, okay? So we're gonna hit the pause button and then we'll be right back. Please don't go anywhere. Did everybody hear that?
Yes.
Yes.
Okay. All right, please stand by. Okay. Is everybody back? Is everyone back?
Yes.
Okay, so when we talk about web applications in particular, there are 5 software code related challenges. We've already talked about input, not validating the input. The cross-site scripting occurs when you have a user that moves between websites, and this happens all the time. So if you are in an Amazon screen and you click on a link to see about a product, sometimes you're actually pulling content from another website. Cross-site scripting is a way for malicious content to hop between the browser client and the website server, and then between the browser client and another website server. So it's kind of like hopscotch, right? So cross-site scripting is where a malicious actor has created a script to embed malicious content in different places along the path, and that makes it much harder to detect. It's also harder to stop. But there are simple measures to reduce the impact of cross-site scripting. Does anyone have any questions about what I mean when I say cross-site scripting? So buffer overflow is something that is technically a part of the same phenomenon. So when you have a buffer overflow and the commands are embedded in there, a lot of times it's because the input wasn't validated, but then on a deeper level, the buffer, right? The buffer executes malicious code. SQL injection flaws. A lot of websites have database backends. There is a database server on the backside of a web page. And SQL is the common language to send and receive a lot of data from the databases. There's a specific attack called an injection attack. It's a SQL injection attack. And then lastly, the biggest problem is, what does your software, this is it. This is like the linchpin right here. So improper error handling. When there is an error, what does the software do with that error state? That is the single biggest challenge you must create. When you look at defensive coding techniques, you are going to have user errors. There will be misfires with the code. The $64,000 question is, when the unexpected happens, does your software include a method for handling the error? If your software does not include the method for handling errors, then you're a part of the problem. And the exposure in software is on you. That blood is on your hands, so to speak, because it's these error conditions that malicious actors can exploit. And if there is good error handling, they cannot. Does everybody understand what I'm talking about? So let me explain a little further. Let's suppose that a malicious attacker inputs bad data to try to execute a buffer overflow attack. And now you have an input with bad data. If you have a temporary variable for input validation, it's going to check to see if the input is correct. If the input is incorrect, it will issue an error. The big $64,000 question is, when a problem happens, not if, when a problem happens, do programmers have a simple set of statements that address, okay, if this error appears, then store null in this variable. Does everybody know what a null value is?
Yeah.
If you store a null value in a variable, what is the value of that data in the variable? And I'm not asking that as a trick question. I just want to see if you understand the term null value, N-U-L-L, null value. Has anyone ever heard that term before?
When there's a null value, it's like unknown, or there is no value.
Yeah,
It's unknown. It's what? That is correct, by the way.
Or empty.
It's empty. That's right. Null means non-existent, but you store it that way. When you store a null value, you're saying, okay, whatever was in there, store nothing in there now. Okay? So that would be a great example of, all right, you have some junk in the input. What do you do? Well, if you have proper error handling, When the error occurs, not if it occurs, when it occurs, the error code triggers another set of commands to store a null in the variables so that you can basically keep bad things from happening. This is critically important. So I just wanted you to be aware that this is probably the single most important slide that you need to remember and study, right? These flaws occur as consequences of insufficient checking and validation with the data and error code processing. And let's face it, error handling is a finer skill. It's a higher order skill. We spend much time teaching algorithms, teaching advanced coding techniques, and error handling is often covered as an afterthought. If we want to secure our software, if we want defensive coding to be a reality, then error handling needs to be a part of our coding method and our education process for coding. How many classes, I'm just asking the question, and this is common practice everywhere, so this is not an indictment, it's not a charge that our coding education program is deficient. It's just done this way everywhere. How far did you go in your coding courses before they started talking about error handling? Was it the introductory course to Java? Did they introduce how to handle errors in the intro to Java course? Does anyone recall whether or not that happened? Hello?
Not,
Okay. If you've had several programming courses, that's a good question to ask. Okay, if an error occurs, no, scratch that. What have I been saying the whole time? When an error occurs, what is a good way to handle the error? Well, you null the values in the variable and you loop back to where people need to input the correct data. Another function needs to clear correct input, okay? Or maybe there's notification. So part of the code for error handling includes automated notification. You get an email or a text, right? So it's a critical step in writing secure code. It's a very simple thing. It's a simple thing. So when you think about it, it's like, wow. So this is something we really haven't stressed a lot, and it's something that we should be doing more. Software developers need to address these known areas of concern, right? So there is a NIST, National Institute of Standards and Technology. There is a special publication, right, that provides guidance. It's 8151. Talks about a range of approaches to reduce the number of software vulnerabilities or software exposures, right? So stopping the exposure before they occur by using improved methods for building, it's the requirements engineering, right? When they say specifying, you're talking about you're engineering the requirements of the software, you're building the software. That's the time to do this stuff, right? You find vulnerabilities before they can be exploited by using better and more efficient testing techniques. So you stress your software. You have a working copy, a beta version of your software, and you give it to somebody and say, here, hack this. Here, try to mess this up. Here, try to crash my system by doing weird things with it. That's testing, right? And if done correctly, it's very methodical. There's actually software that's designed to test other applications. You want to reduce the impact of the vulnerabilities by building more resilient architectures. So when you're creating software, it depends on resources, named resources. What happens if it doesn't have a named resource? Does your software say, hey, this is an unsafe condition, maybe you shouldn't do this. Now, after the fact, when an attacker discovers an exposure, or they're reading about the bugs, they look up the CVE, the Common Vulnerability and Exposure, this company called MITRE, M-I-T-R-E. It's spelled M-I-T-R-E. There's an index of all the software problems, and those are exposures. Attackers reference those before coders do, right? So what should coders do? They should, if they're coding to maintain software, they should look up the CVE to see what it is that needs fixing. Why? They don't want to create new code that has the same problem. That's really, really bad. Version 2.0 had a problem. 2.1, the patched version, fixed it. Then we come out with version 3. Version 3 has the same darn problem all over again because they weren't paying attention to the common exposure, right? So what we're saying is that when you're creating new versions, you want a checklist, right? You want to have structured intentional testing. And the concern is not how many bugs, but how often they are triggered. So you might have a specific exposure or a bug in your software. And if you have logs that show that it's really being hammered, that's the one you look at. That's this last item right here. Does everybody understand what that means? Okay, so defensive programming, one of the things that I want to show you, and this is just something that we're going to do, all right? The key rule is to never assume anything, check all assumptions, and handle all possible error states. When you work through the process of doing all of this, it's called secure programming. And it has attention for all aspects. Here is a great example. And at this point, I'm going to stop. That's all I want you to focus on for chapter 11 is the concepts we just covered. Now there's additional information after this, right? There's really cool stuff, really pretty diagrams, right? About the interactions between the software components. And then it provides additional insights for what programmers should do. And I encourage you to take a look at the rest of the slides. But it's really just this and the previous couple of slides where we just stressed a couple of very basic things. That's the main thing. I want you to keep the main thing the main thing. And that's what I'm going to add to the study guide. I got to show you a quick example of how crazy this is. So you have to think of every aspect. And right here in this section, we added the link for the MITRE CVE website, right? So you'll know where that is. How many of you are familiar with Access? Does anybody know? Has anybody ever heard of Microsoft Access?
I heard of it, but I never used it before.
Yeah, I just heard of it.
Okay. So I have Access, and I'm gonna look for, oh, hang on a second. Access. I should be able to type in Access. And there's the app. Okay. So Access is a database. It's a relational database management system, or RDBMS. And it's a complement to the Microsoft Office application suite. So we know that word processors deal with documents, and we know that Excel deals with spreadsheets for numbers. Well, different kinds of data are ideally framed and managed with a database, right? A database application. And when you have a database application development resource, you can create databases and do all sorts of things very quickly. Now, what I'm going to do is open up a basic new database, and I'm going to create a new table called table 1. Okay. And I'm going to go into this design view, and I have to save it as table 1. So I'm going to accept, well, here's the first thing I'm going to do. This is a table object, so I'm going to name it first table. First data set, okay? Let's pretend I'm doing something for healthcare or finances. Everybody with me? Small t for table. Small q for query. Small r for report. Small m for macro or script, okay? You want to use an intentional naming system for each of your database access objects, just as you would if you were creating variables and you want to name your variables sensibly. You know, what kind of data is in it? Use str for string. Use rel for real number, something. And always for the object or variable name, let's call this user demo graphics, okay? Does everybody know what the term demographics means? Okay, we're going to say user info, okay? Demographics is a fancy name for info, user information, their first name, their last name, their address, their email contact information, their cell phone number. Is everybody with me so far?
Yes.
Okay. So I'm in the design view, okay? And I've just created the name of the table, and it's called T user info. So I know this table is going to store user info. And the first field is created for me automatically. But I'm going to put in F name for first name. Everybody with me?
Yes.
Okay, and then what comes next? First name, then what? Last name, right? Can everybody see first name right here?
First name.
Yeah, as
Yeah,
soon as I put a label in there that hinted about what this is for, Access automatically said, oh, they're going to put text information in here. They're not putting in automated integers that increment with each entry. So I have record 1, record 2, record 3. Every time I create a new record, it's an auto assignment of a unique integer, a unique ID number, right? So I'm going to put ID number, right? And I get a unique one each time. So if I have 47 new users, I have 47 ID numbers. Everybody with me? And the auto number automatically assigns a long integer. But let's pretend that this database, I'm designing this software for just a dozen people. Are you with me? A dozen people. Do you think I need a long integer data type, or could I use less? Could I use like a short integer? So I'm not storing as much data. I'm just asking the question, right? So do I have to use the biggest size of integer, or can I just use, now Access doesn't give you many options here, but let's look at first name, okay? First name. The default for Access says, oh, it's about a name, so let's use a short text data type for this field. It does this automatically. Can you see how many characters are the default size for that field? Hello?
Yes.
What's the number you see that I just highlighted?
55.
255. Have you ever heard of a first name that requires 255 letters?
Nope.
Nope. How about a last name? Let's look at the last name. Have you ever heard of a last name that requires 255 letters?
Nope.
No.
No.
But see what Access does? Access automatically puts in a generous amount of resources. So if there's a longer first name, if there's a longer last name, then your database will not have an error and cease to function because somebody types in, oh, I thought 25 letters was long enough and now there's 26 letters in the name, and the database doesn't do well with 26 letters in the name. So what Access does is it creates a notional field size. Did you know that that field size reserves additional memory? When you say you need 255 letters for a last name, did you know that in some situations with coding and programming like this, it creates a lot of memory address space? That's like creating a lot of extra network addresses on your home network. It's an attractive nuisance. It's extra space for them to overflow the buffer. Hello? Inject some SQL commands. Hello? What would you say is a reasonable length for first name? What should I put here? What's the max length for a first name you can think of? And let's be safe. Let's be conservative. Let's say, okay, this is for the general public. What do you think is a safe number of letters for a first name?
First name, um, 5, 10?
Yeah, not very many. I mean, maybe more than 10. What's the longest name that you can think of? All right, so watch this. Here's what I'm going to do. What do we do if we need to find out? Well, we go here, of course, right? Or you can go to Bing, or you can go to your favorite search engine, DuckDuck. Longest first names in the world. Okay? Wow.
That's too long.
Wolfeschlegelsteinhausen Burgerdorf. That's a last name. What a last name, right? Now, I mean, seriously, how many long names are we going to have like that? Let's just say just long first names. Let's search for long first names. Long, common first names, not weird ones, okay? Not the Guinness Book of World Records. Emmanuel has 1, 2, 3, 4, okay, right? 101 long names for boys that earn every letter, right? So very long names. Alexander, Christopher, there's a lot of letters, right? Have you ever seen somebody that has a hyphenated first name? Like Julia Ann or something like that, right? Sebastian, Theodore, Nathaniel, right? In the Bible, has anybody ever seen the names in the Bible? You have names like Mephibosheth, right? Methuselah. You have long names in the Bible. The point I'm trying to make is you still only need, I would say, to be safe, 24 letters. Would you agree that 24 letters would probably be plenty? Even if there were hyphenated first names. And what's the difference? Well, each letter is a byte of coded ASCII text information. Now I'm oversimplifying here, but if I take 255 and I subtract 24, I am conserving, I don't set up 10 times as much memory space as I need just by accepting what? Just by accepting the default, 255. This is one example of craziness. Craziness. It's why we have problems with our software. We accept our coders are not taught to just do a little extra research, just do a little extra homework, and every aspect, every single aspect of our coding, we should question, we should check, we should ask, do I really need that much memory? Do I really need that much file space devoted, right, for a given data type? And that is the end of our chapter 11 content that we will include in module 2. Now we're going to revisit this later on in our course in the special topics module at the very end of the season, okay? Is there anyone that can think of any questions or comments based on the material presented? Okay. Now what I'd like to do next is to close this, and I would like to go to here, and I want to go here, and I want to ask, would anyone care for additional assistance today, tomorrow, when it's convenient? So you can finish, everybody responded to 2.1. I'm glad that everyone submitted something for 2.1, but the 2.1, I mean the 2.2 solution, it seems as though no one has submitted yet for the 2.2 solution. And here is the step-by-step video to set up a virtual machine. I would offer to each of you, if you cannot run your own virtual machine, you can send me an email and I will set up hello, who is Zoom user? Zoom user, can you identify yourself? I don't have a microphone. Is that Miss Lady? Is that Miss Lady?
Yes, it's me. I just transferred this to my phone.
I gotcha. Okay. I'm glad you're still in the mix. I want to share this with you. If you cannot build a virtual machine with Server 2022 on your laptop or your PC, I want you to send me an email and tell me that you would prefer to set up a virtual machine on a host that we have. You can remote to, so you can access this remotely. If your laptop or your PC is not capable, if it does not have as much disk space or RAM to create your own simple virtual server, we can set up a separate machine for you to use to finish the steps in the 2.2 solution. But I would like you to go ahead and try to do it on your own laptop or your own PC. If you've done that and you get stuck, you can send an email, and for the first task, task 1, you can say, my PC, my laptop is incapable. I have tried, here are my screenshots. I've done this. I don't have enough disk space. I don't have enough RAM. It's an old laptop, whatever. You can just send me a quick screenshot, and then you can request my assistance to set the stage for you to build your own virtual machine on our platform instead of your laptop or PC. I wanted to offer that to you as we clear for spring break. I do need that email soon. So if you are struggling with the 2.2 solution and you cannot finish it before this week is out, before Saturday runs out tomorrow, please send an email that says, yes, if I can use your platform to create a Microsoft Server 2022 machine, I would like to schedule a time to walk through that with you. and we will build that together on our platform. And then you'll capture a screenshot of that when it's finished, and you'll log the 3 points. And then you'll be able to do the second task and the third task for the remaining points you need to finish, okay? The other thing that you can do is that you can say, give me a Raspberry Pi. I want to set up a Pi hole in my home, and I will get you a Pi hole. I will get you a Raspberry Pi and then send you the steps to set up a Raspberry Pi that runs Pi-hole so that you have DNS service on your home network. You have a more secure home network. Is there anyone that knows? All right, so I'm going to stop recording and stop sharing. If you'd like to know more about these options, stay on the screen and we can coordinate right now. Okay, I'll make this easy. You can talk to me right now and we can work through the process to make sure that you have what you need. I want you to finish your solution as soon as possible. So when we come back from spring break, you have the resources you need to do the rest of the hands-on, because you will not be able to do the module solution for module 3, module 4, module 5, if you don't have something to work with.